Hi, I'm Guo Cheng Guang, 12 years old, secondary 1 from NUS High School. Right now here. Still continuing with our theoretical mechanics. Well, in our theoretical mechanics, we are still at chapter 1, kinematics. Well, in this part, we have shown for these three formulas before. But let me just tell you again, what is this about? So, in this part, from, let's just say you're standing at this so-called origin, then you throw one thing. Well, you make a projection or a projectile. You ignore the air resistance, there's only the gravitational force acting on it. Then you get these three formulas which we have shown before. But let me just say again here. This first part, th that part, it is the time taken for this body or this object to reach its maximum height. So it reaches its maximum height. Then for the second part, y maximum, well, it's just what is that height for its maximum height, what is it? Then for this last part here is x maximum. Well, this x maximum is from this projection. It goes all the way to this end. It's just this length from here. Well, it may be set as the displacement since, well, it's still from the origin. But it's just this distance from the starting part to when it ends, like you can say it's on the ground there, possible. So, well, I'm just going to show for one case here, x maximum. So the maximum value of x. Well, in this part, how can we get its maximum? Now, sine here, theta, is only from 0 to 90 degrees. So that means sine, its maximum, well, is 1. So it ranges from 0 to 1. So then, well, we want to get maximum, well, let me just write this down. Its maximum is 1, so it should be smaller or equals to initial velocity square over g. So that will be for this part here. And this part, when we want to get maximum for this x part, maximum for here, that means 2 theta would need to be 90 degrees. Then theta would just be 45 degrees. So that means at this part, when theta is 45 degrees, it goes the furthest. So that's when it goes the furthest. Well, I'm just going to use this as an example. For here, this case, well, let's just think. You didn't shoot accurately, then you accidentally missed by a delta theta, this angle. So in the first case, you have what if you extra go upwards and delta theta. So the angle you have right now, actually you're using here, so 45 degrees, what if we just use it in the pi? That means it'll just be pi over 4, then you go extra, so you add delta theta. So this will be the angle that you will have now. Then you want to find this part. So you want to find this part for that. Here, x. So sine at this part 2 of this. First part that we can use will be to times this thing in, times this 2 inside. Well, this other part, including this initial velocity part and this g part, I'm just going to leave it on the outside first. So in here, what you will get will be sine pi over 2 add 2 of this delta theta. Well, this part, what can we use here? We use something about sine. Well, let me just tell you what we're going to use here. Sine pi, you add an... Wait, I mean here is subtract. Here you subtract an angle. What you have left will be sine this angle. So you might think, wait, how can we use it here? This is an add. Here is a subtract. Well, let me just tell you, we work back. So when we work back here, since they are equal, so yes, we can go in both ways. When we go backward, so that means it's pi minus this thing. Using pi to minus this thing, you still get half pi in front, but behind here, we'll subtract 2 delta theta. Then in this part, you can leave it like that, or you can just choose to change it. You can choose to change it into cosine, and here will be 2 delta theta. You can choose to leave it in either form. Then let's check what if it gets lower by a delta theta angle. So then you get x pi over 4 subtract delta theta in this part. So this will be equal to, so still we're going to use this part. So in this part, if you have realized it immediately, it's just the same as this part. Well, you can choose to just continue on, or you can just straight away say that these two parts are actually equal. So that is why just now I've said this part you can actually just leave it out. So right now here, we have already shown that these two are actually equal. Okay, so we have shown that when you shoot higher, well, it goes to the same part. You shoot lower, it goes to the same part as well. So for these three parts or these three projections, the first part for this is just this at the angle of 45 degrees. So when this is at an angle of 45 degrees, you can go like this. Then after that will be 45 degrees, you subtract delta theta. Then it goes like this, maybe. Then after that, higher, which is at 45 degrees, then you add delta theta. So this part is where they both end. And then this part that we have here. So each of these three, well, what's so common about them? It is that each of them, they have the same initial velocity, and it has to be the same initial velocity for each and every one of them. The only difference between these parts is that the angle that they start with, they are different. Well, let me just say about these parts again. Well, the first that we have here is TH. Well, TH, it means the time taken to reach the maximum height. This maximum height, for example, this graph here will be around here. So the maximum height, it will be the time taken to reach here. In the second part, it's just the maximum height. So that will be the whole part of this part. The third here is, well, x maximum. It is just this maximum length on the horizontal axis, whereas the length is on the same horizontal axis. This will be x maximum. And just take note again that for all of these parts, we are just ignoring the air resistance. You have to be aware of that. We are ignoring the air resistance between all of these. So in this part that we have here, I hope you understand so far. And I'm just going to end this lesson here. Thank you for your watching.